In this video, we're going to talk about absolute value inequalities. They look very similar to absolute value equations actually. For example, we could have 2x minus 1 equals 4, and we already solved this kind of equation in the last lesson. But this lesson we'll learn how to solve the inequalities. Okay, we'll do some example with the number line first. And there's two kinds of problems. There's less than problem and greater than problems. Okay, so what this is asking is we want to find absolute values that are less than 2. So using the number line, we'll check sum. This number line represents the x value. So if you put 0 into the absolute 0 is 0, and that's less than 2, so that's okay. Absolute value 1 is 1, which is less than 2, okay. Absolute value 2 is not less than 2, but it will be an open circle value, because you could use 1.99. Absolute 199 is also less than 2. So we'll go up to 2 but not include 2. Going in the other direction, minus 1. Absolute minus 1 is 1, which is less than 2, no problem. Absolute minus 2, we have the same issue as on the other side. So we'll have an open circle here. Any value between minus 2 and 2 will be part of the solution. So that's written as minus 2 less than x less than 2. And the question was absolute value x is less than 2. And this here is the solution. So x is any value between minus 2 and 2. For the next question, absolute value x is less than or equal to 3. Again, we try a few values. 0, so put 0 in here. Okay, absolute value 0 is less than or equal to 3. 1 is okay, absolute value 1 is 1, which is less than 3. 2, absolute value 2 is less than 3. And 3, absolute value 3 is less than 3, which is also true. So up to this point. So all of these are okay. And try the other side. Absolute value minus 1 is 1, which is less than 3. Absolute value minus 2 is 2, which is less than 3. And up to, or down to minus 3. So if your question is absolute value x less than 3, the solution, x must be between minus 3 and 3. For greater than problems, we do the same procedure. So let's try some values. So what about absolute value 0? Is that less than, greater than 1? No, not this value. What about 1? Absolute value 1? Is that greater than 1? Well, no, but that would be the starting point because the value is equal. How about 2? Absolute value 2 is 2, which is greater than 1. Okay. Absolute value 3 is 3, greater than 1, yes. Absolute value 4 is greater than 1, and so on. It will go to infinity like that. So all of these values will make this inequality true. In the other direction, absolute value minus 1 is 1. Well, that's equal to 1, so this will be the starting point. Absolute value 2, negative 2 is 2, and 2 is greater than 1, so that's okay. Absolute value minus 3 is 3, which is greater than 1, and so on. So all of these will be true as well. So notice how your line has been broken into two parts now. So if your question absolute x is greater than 1, the solution would be x is greater than 1 or x is less than minus 1. So this is the x greater than 1 part, and this is the x less than negative 1 part. So that would be your solution. So in this question, absolute x must be greater than or equal to 4. Well, 0, no. 1, no. 2, no. 3, no. But 4, absolute value 4 is equal to 4, so that's your starting point. And absolute value 5 and absolute value 6, both of these are greater than 4. So that would be part of your solution. In the other direction, absolute value minus 1 is 1, which is not greater than 4. Absolute value 2 is 2, not greater than 4. Absolute value 3 is 3, no. But absolute value minus 4 is 4, which equals 4, which is okay. And then absolute value 5 is 5, which is greater than 4. And also for minus 6. So if your question, absolute value x is greater than or equal to 4, the solution is x is greater than or equal to 4 or x less than or equal to minus 4. Okay, let's look at some general rules. These are 2 rules that you can use that are based on the previous discussion. If absolute x is less than k, k is some value, the solution will be minus k less than x less than k. Similarly, if you had a number a, note how x minus a is written in the middle, and k becomes negative k on this side and k on this side, and that will give you the solution. So let's look at some examples using the rule. So x plus 2 less than 4, so this rule applies to less than problems. So the minus 4 would be written here, less than x minus a, which is x plus 2. So write the x plus 2 in the middle, and the 4 would be written here as the positive value. And we just solved that. So notice we got minus 4 less than x plus 2 less than 4. We've got a 2 here, so we subtract 2 both sides to give minus 6 less than x less than 4 minus 2, which is 2. So that's your solution. So any value between minus 6 and 2, this inequality will be true. Again, in this question, we write the minus 5 here, less than 2x plus 3, less than 5. So now we've got a 3 to get rid of, so subtract 3 both sides, as you did at school. So minus 5 minus 3 is minus 8, less than 2x, less than 5 minus 3, which is 2. You've got a 2 to get rid of, so divide everything by 2. Okay, minus 8 on 2, minus 4, less than x, less than 1. That's your solution again. So any value between minus 4 and 1 will make this inequality true. In this question, we have a 3 to get rid of first, so divide both sides by 3. Cancel the 3 here. Do not cancel anything inside the absolute. So 3 will cancel. Absolute x minus 1 less than 12 divided by 3 is 4. And so we use the same procedure. So write minus 4 on the left, x minus 1 less than 4, and solve. So cancel the 1, minus 4 plus 1, minus 3, x less than 4 plus 1, 5. Okay, so this is how you do the less than problems using that procedure. For greater than problems, the formula is a little bit different, as we saw on the first page. If x is greater than or equal to k, the solution will be x is greater than k or x is less than k. Okay, so that k will be written here and also here. And this should have been changed as x minus a. So let's fix that. Okay, so then the solution would be x minus a greater than k or x minus a less than minus k. So you can fix that yourself. That's what it should be there. forgot to change it. Okay, so using those formulas, so x minus 3 greater than 7, there were two parts. The first bit is the positive part, so x minus 3 is greater than 7, so x must be greater than 10, or x minus 3 is less than minus 7. That's this part here, the minus k part. So x would be less than minus 7 plus 3 would be minus 4. So either x is greater than 10 or x is less than minus 4. That will make the inequality true. In this case, again, so 4 minus x is greater than or equal to 12. So minus x greater than or equal to, move the 4, 12 minus 4 is 8. You can divide by minus 1, so to get rid of the negative sign here. So then you would have x, let's do the whole thing, minus 1, greater than root of 8, minus 1. Cancel the sign, x, but because you've divided by negative, change the direction. Oh, let's do that again. Sorry about that. Let's just start again. Minus x greater than or equal to 12. I think I made a mistake. Minus 4. So minus x greater than or equal to 8. So divide by negative 1. X less than or equal to minus 8. That's that part. And the second bit. 4 minus x less than or equal to minus 12. So minus x less than or equal to minus 16. Divide by negative 1. So x greater than or equal to 16. There. That's the second part. Okay, for the next question, we've got a 2 here, we've got a 9, so we need to move the 9 first. So 2, 3x minus 1 greater than 10. Cancel the 2 by dividing by 2. So 3x minus 1 greater than 5. Okay, so either 3x minus 1 is greater than 5 or less than minus 5. So 3x greater than 6, x greater than 2 at the first bit, or 3x minus 1 less than minus 5. But you don't need the absolute sign. Get rid of that. 3x minus 1 less than minus 5. So 3x less than minus 4. So x less than minus 4 on 3. That's the second part. You don't need to make the number line for the solution here. You can do, but you don't need to, unless I ask for it. Okay, so these are some of the questions for you to do. Use the two formulas on the previous page and have a go at that.